My name is Don Murdoch. I'm a GSE SANS Sec 530 instructor, been around SANS since 2003. I actually wrote papers back when that was a requirement way back when, as my colleague Laura reminded me when I saw her today. Anyway, so what I'm going to do is go through and present for you a discussion on incident response from the cloud as your data center. This is the abstract that we put together for the talk. I like to leave these in talks for people to go and find out what the talk is about. So from a agenda perspective, I'm going to give you a couple of cloud security incident case studies. And some of my things are going to echo the previous speaker, which is kind of interesting. We have two people, two different perspectives telling the same story. There's some truth to that. We'll dig a little bit into what the top 10 cloud issues look like. And I've got a great reference from an RSAC presentation a couple of years ago. We'll talk a lot about patterns of IR and those sorts of things and various log sources. Now, as I go through this, my slide deck is dense. I am not going to hit every single thing on the page. I really like to put together these slide decks for the summit, mainly so that when it's done, you can download this later on and really dig into it. So don't expect me to cover every single hint. So from an incident case study, right? We used to depend on privacyrights.org way back when as one of our organizations that did a great job letting us know what was going on in the incident response space. They're doing some re-architecting, so I went and found a current source. UpGuard is one of those cybersecurity rating services that's doing a good job keeping track of this. When I first started putting this talk together about 6-8 weeks ago, they had the top 66 breaches. When I went through to check all of my spelling errors, and apparently I missed one here on this page, they had the top 67. So they're one of the places where you can get some pretty good idea of what's actually going on. By the way, when this becomes a PDF, that's going to be a clickable link when you're done. So I pulled out a couple that have some themes that you see in data breaches. Yahoo is a good example. Yahoo had a breach in August of 2013, where they estimated about 1 billion accounts had been compromised. That was discovered during some due diligence during an acquisition process in 2016. And what happens when you have a due diligence process? You dig and dig and dig, and it turns out 3 billion accounts was actually the final number released about August 2017. So from a complexion perspective, the situation that you know today will change when it comes to these incident response. ADAR, and that's actually supposed to have a second A after the D. That is the unique 12-digit identifier in the country of India on the opposite side of the globe. So what happened is ADAR is empowered by an agency for India to collect biometric data on citizens to have a unique identifier. And they were actually compromised through a sub-processor. A state utility company caused their biometric data about the Indian citizens to be leached and breached out of the environment. So here, another theme that you see in this cloud-based incident response, what happens if a sub-processor is breached? Up here in the military, that's part of how the F-35 Joint Strike Fighter plans were leaked. Although leached, that's an interesting word. I might use that, leached. Maybe a new term for us. So a couple of case studies here that have a unique complexion. CodeSpaces was a platform as a service organization. I'd never heard of these people. I had no idea there was such a thing. As it turns out, we believe that some attackers actually found some credentials either in a public GitHub or some other repository. They used those credentials, they logged into the environment, figured out some stuff, found a custom-built console that was in a default mode, and they started interfering with the CodeSpaces environment. They deleted some data, attempted to extract money from CodeSpaces, and CodeSpaces obviously didn't want to comply with that. Their incident response team figured out that they were confident that the attacker hadn't gained any private keys. So what they did was changed all the credentials. They missed the fact that the attacker actually had a variety of back doors in place. And then what the attacker did was they executed a burn down at, I like to say, at the speed of code. Think about this. If you can identify 100 resources and you can issue 100 delete commands from 100 unique source IP addresses with the credentials, AWS is going to respond and delete 100 resources in parallel. So that's a pretty devastating attack. These people closed their door. Another one with a different complexion. Here we have Redlock found a variety of Kubernetes clusters that were available on the Tesla environment. These were Kubernetes clusters that had been stood up on top of EC2 instances So Tesla wasn't using native services. Many cloud service providers have native container services. Amazon has 3, and they weren't leveraging that. So as a result, these Kubernetes clusters were available on the commodity internet. We know that because we have a beautiful screenshot there. How about that? With some stuff highlighted. And what these things had long-term secrets built into them. It's an important term in the cloud space. We have short-term secrets issued by a service on demand, and then we have a long-term secret, our credentials. So, we need to think about different types of secrets that we have in these environments. Sure enough, what this attacker did was they leveraged that environment to install a bunch of coin miners, but because of the long-term secrets, they could have done a lot worse. This is another really interesting one, and it has something unique to it that's part of the top 10 issues. Cap 1, what's in your wallet? They fell victim to a server-side request forgery attack. Not only did they have a bunch of data that was leaked, as you see there on the top of the slides, and this is pretty famous. My slides aren't moving forward. Thank you so much. Dual-handed. This is my first time doing dual-hand Prezzo. Anyway, so what you see there on the slide is a reference to a PIPA address. Now, what's interesting about these cloud environments is EC2 instances can go ahead and ask questions of the environment, and that's exactly what the attacker did. So through a server-side request forgery vulnerability, they were capable of learning things like VPC IDs, IP addresses, short-term secrets, all that kind of stuff. Now here, the attacker bragged on this on a forum. Somebody, identified them to law enforcement, and they were caught. But recently, Cap 1 was fined $80 million for this breach. So something was taken out of their wallet. Hey, I got a laugh. That's great. So you're seeing the beginning of a theme here, right? Credential leakage, same time, this is great. Credential leakage, big deal. Like our previous gentleman spoke about, right? Credentials, because if I can get those credentials, those long-term secrets, cloud environments today, it's not the web UI. If you're getting to learn how the cloud thing works and how AWS works in Amazon, you're going to use the user interface. It's, after about 3 months, you're going to be doing automation is what we really want you to be doing. I have examples of that in here. So once we have that, it's not very hard to execute lateral movement. Well, let's dig into that a little bit further and ask ourselves, is there a top 10 list? Yeah, there is. And Rich Mogul and Sean Harris, it actually tells you where they're from. They put together a really stellar Prezzo at RSAC about 2 years ago. So I pulled out the main top 10 points that they talked about. And you can see here some of the things that I've given you some examples of. Credential exposure, credential leakage, server-side request forgery, server compromise through exposed services. Yes, Virginia, people do put RDP on the internet. I don't know why they do this, but they do, So I want to break down the first one, and then you really should go check out their Prezzo from RSAC. They have a great breakdown on each one of those top 10 vectors. So if we look at this from a kill chain perspective, we want to ask ourselves, what can we do to find and prevent those problems from occurring? Anything like an e-discovery app that you use, you can go search your environment. There's tons of functions in the various cloud providers. Macie is a good one for AWS. There's secrets detection in GitLab. Basically, any place that you store a key, you want to be able to automatically interrogate that location to find out if keys are available. So I wanted to give you another way of looking at this, and this is kind of pulled out from our Sec 530 and Audit 507 class that we have here at SANS. Think about time-based security. When Schwartau, that's how you pronounce his last name, came up with a model a couple of years ago, and this works really, really well in the kinetic space. You want your protection time to be greater than your detection plus response time. So if you look at this from a kind of in the kinetic world, we have our attacker on the left-hand side who steals a safe. If that attacker is capable of taking that safe away, you might know that as a bunch of EC2 images or AI images, or your data, or the contents of your EFS store or your database in the cloud space. If they can take that away quicker and pull that off more quickly and more readily than you can detect that and then respond to that, they win. So why is this so important? Why am I harping on this stuff? Has anyone done any research? Sure enough, our guy out here Paul Bischoff wrote an article, clickable link, you can go read about it. He did a design of an experiment and said, how quickly does it take for someone to take credentials and leverage them? So he stood up an early warning system. Now on the slide, it says honeypot, but I want you to kind of get conditioned. We never use that term when we're speaking to senior management. We talk about early warning systems. It's very important. HONEYPOT is verbalized early warning systems. Why? It's a lot more palatable, and we're not using the phrase deception technology. So what he figured out was, sure enough, sub 1 minute time from credential leakage to credential exposure. And that's a regular pattern that you see there on the slide. So that's examples of things that you could search for. They also found that attackers weren't coming from the same address. Over 500 unique addresses were leveraging these keys. That's very difficult to defend against. So that brings us into the idea of detection engineering. Now, there's a lot of definitions in this space. You can read article after article. From a reference perspective, I went and got 3 sources that I think know a clue about it. And I came up with my own kind of a working definition. See, I told you I wasn't going to read every slide. This detection engineering is a systematic process. You have a thought process. You're thinking about something. You're going through, you're identifying the valuable assets. What's value to you? They're the items that tie to the value chain. What is the value chain? It is the mechanisms in your organization that take raw goods and services and transforms that into something that is viable in your market. That's like very much an MBA concept, but if you want to be business relevant to your senior leaders, understanding what your value chain is and talking about how you're protecting the value chain is something they care about. That goes from, that's my gray hair piece of knowledge for you, right? Anyway, getting back to this. Well, knowing what those valuable assets are, understanding the protective mechanisms, whether they exist or don't exist, in order to determine how to detect activity to identify an attacker. So that's kind of what I'm my working definition of detection engineering. I'm mashing some of those definitions together. Break that down, and it's subject matter expertise. We like to call that wetware. It's the stuff between your ears. It's not necessarily between your ears. It's also in between the ears of the security operations people, your cloud architects, the folks designing and building things in cloud. I just came from a 2-year stint at a software development firm. You may have heard of them, RSA, been around a while. I would actually work routinely with our people, and we would spend a fair amount of time doing threat plan analysis for the express purpose of ensuring that products that we were developed had very specific, narrow, controllable pathways in to make sure that we would minimizing that attack. Now, you've also got observable and measurable events. I'm going to break that down in the second slide for you, and I have some other examples later on. We have to have a detection engine that is enabled with telemetry. Telemetry in our space is one of 2 things. It's an event of interest that's published from a logging source, or it's a question that we ask our environment in a reliable manner to understand a security state. You have to have an area of focus. Shotgun approaches don't work. Start with the most valuable resources, things that enable business processes. And the last thing you have to have is some descriptive language that can mine that data source. So from an observable behavior perspective, we have 3 types of behaviors. We have an atomic behavior, root login, MFA change, singleton events that can turn into a detection point for us. We have statistical analysis. Now, I don't know how many organizations we have here, but we've easily got close to 5,400, 5,500 people participating. The statistical analysis of how many EC2 instances you start one day is going to be variable. There is no one-stop answer. There could be some organizations here where you start 300 EC2 instances and burn them down every day. There could be organizations that start 3 a week. So you have to know what your environment is, to know what your baseline is, to know what is a significant bump up. And then behavioral analysis is when you take a bunch of individual pieces of source data, maybe from different systems, and you collect them together to say, that's fishy, that's an attacker. And I have some examples of those coming up. So top 10. So first you got this, general exposure, then we have our top 10 list, and then we dig it further. MITRE ATT&CK. They're getting a lot of press today. Why? They have top quality thought engineering in this space. There's a variety of cloud matrix models that the MITRE folks have put together. They kind of got their start with enterprise attack many, many moons ago. But anyway, each one of these tool tactics and procedures, you can break those out, click into them, get a reading, get a description, find out what's going on, and it tells you example trace data. So from a macro level perspective, when you're doing incident response, there's generally a model that you want to follow. First, it's what's actually going on for the accounts in my environment. What happened? So how do I do that? So how do I go query that data? How do I go find out what account was misused? That's like an important job skill you have to have. The next thing we're looking at, what happened in the cloud platform, then it's resource management. So in terms of thinking about what I like to say, prosecuting an event, this is the general pattern that you follow. So automating the first step in automating your data collection and analysis techniques is going to help you out in the long run. Microsoft Office 365 is one of those log sources. Microsoft is very proud of the fact that they have, tens of thousands of customers using unified audit log. And if anything, the recent Exchange vulnerabilities are pushing more people to the cloud. The UAL is where a lot of this data is stored. In cloud accounts, data is not available immediately. Unlike the Windows security log, when you create an account, an Active Directory, you have an event, it's published to the log sub 1 second, guaranteed every time. That's a whole different world in cloud accounts. Some of these event pieces of activity in the UAL can take up to 30 minutes to be pushed in. Some of them can take up to 24 hours. Now, the Microsoft guidance that explains this actually gives you the very specific list. But you could ask a question right now at 11:30 or 11:40, whatever, 11:30, and you could get 900 answers about 900 unique users. And you could ask that same question at 6 o'clock tonight after dinner, and you could get 1,200. So there's a certain amount of time that it takes for all this log data to get through. Okay, this is turned on by default in October 2021. So if you have a Microsoft account for 365 and your account was created earlier than that date, you do want to make sure this is turned on. It'd be a great thing to look at. Okay, from a user interface perspective, it's bland. There's not a lot. The money, though, is the audit data field, and that's what you're going to have to pull down. So this is what you do on Monday next week. We go ahead and we look at this tool, we can start to explore the data. Then very quickly on Tuesday, we actually move into using some PowerShell. Because using a user interface to point, click, wait, download a CSV, that's not the way to handle an incident. Writing automated code, having code that you can use is a great way to do that. So here's a great place to start. Specify start, end dates. There's a little bit of PowerShell math to go look at the last 7 days in the second one, and to pull out data in JSON, which is machine readable, one of our criteria for detection engineering. We really want that. Some fields to note, the workload field will drive different field sets. Based on the workload, you're going to see different field sets of data that are going to become present and visible to you. It's not just the exact same field set for every single data source. Something to be aware of. Time is in UTC. There are some FOSS tools, free and open source is what that stands for if you didn't know. The Dark Quasar tool, one of the neat things about this tool is it is designed to be used as a playbook tool. There's two that they've written. One is focused on e-discovery, and the other one is focused on pulling data for an individual user for their login activity. And then if you look at the Tesserun cert utility, theirs is designed to go pull all records for given user accounts. Now the soft elk tool, Phil Hagan came out with that for Forensics 572, I don't know, 5-6 years ago, something like that. It has some really good load scripts to pull this data in and give it to you in a Kibana user interface for great analysis. So you can take this data, pull it out, drop it off in the cloud. Don't bring it to your workstation, push it back to the cloud. That's a really bad idea. Drop it off on shared storage, pull it into SoftElk, and then you have it and you can analyze it, because you want to avoid pulling that data across from your workstation. A couple of app notes that you should be aware of. If you think about Teams is really that overlay on top of a bunch of these applications. You may not see the source data you want in a Teams log. You're probably going to go see that in SharePoint, Outlook, OneDrive, something like that. So be aware of that. Not all the data is available. A lot of it's recorded in the source system. Microsoft Exchange, one of the fields that is really valuable for us is mail item accessed. It's every time you actually open up a message. Now you only get that if you're using an E5 license, but it is really valuable, and I'll be able to explain why in a minute. Azure AD, There's a couple of different types of logs. The security log is really good for detecting suspicious activity, identifying compromises, things of that nature. The activity log itself is that tenant history level stuff. Your result status is your key field, whether something was occurred or not occurred. One of the interesting little pieces of Azure data that you can see, it is possible to log in on the console with a successful username and password, but fail an MFA check. And you can actually see that in the log, which is kind of cool. Now, the next thing, once you really get cooking with this stuff, you pull stuff out with the Graph API. Unfortunately, you don't get read events with Graph. Like under AWS, you can see who ran discovery commands. That's just not available. So for Office, I've got a couple of slides on some things you want to look at for incident response detection. Change in audit status. Is it turned on today? That's a little counterintuitive. It's the audit disabled field that should be false. So make sure you know how that field works, whether or not auditing is enabled. You could create a rule specifically for that. Who has read whose mail, or who has read whom's mail, however that works. You guys know the grammar, we're flexible here. Does it expect it? You'll have admin assistants reading executive staff mail, but is that occurring elsewhere? Because that's a big problem. One of the other nice things about the Microsoft 365 logs is for email access, the client field actually tells you how the user gained access. So there's a variety of user agents that you can see there. Forwarding, big deal. Attackers love to do that. I got a breakdown of what that actually looks like by event specifically for business email compromise. Attackers like to set up forwards. Forwards should not really happen that much. Who else likes to set up forwards? The consultants that you hired for a project. Think about that. They like to do that. I myself have done it, So the key event data here is the update inbox rules event. That's one of those events that will be written to the log when people set up forwarders. You can block this at the domain level, but it is possible to unblock it. So you would look for a drop event for this particular setting at the domain level, which means you'd probably want to figure out how to test that, okay? Now for a BEC, or a business email compromise, that's a new term some of you may not have heard. New acronym today. We want you to be acronym compliant by the time you leave. Second joke, I love it. You've got user normally logs in with the same user agent. How many of you actually read email on Monday on your iPhone, and then on Tuesday you read it on your Android phone, then on Wednesday it's your Windows PC, and on Thursday you go and you buy a Mac, so you've got, that doesn't happen. It doesn't, I read email on my phone for 3 jobs now on an iPhone. Why? I'm not going to go out and spend $2,000 on an iPhone and a Samsung Galaxy 3. Samsung would love me for doing that, but I'm just not going to do that. So your users are going to have very small numbers of unique user agents. Might be a good idea for long tail analysis. How many unique agents do we have in our environment? What can we do with that specific data? Home office users in the era of remote work. Your home office location will not change that much. It will tie back to an ASN, an autonomous system number, through an IP address. So it's one of the things that you can see if people are working at home or if their accounts are used in different environments, their ASN will change as well as the IP. Geographically improbable travel. Please be aware though that if you really look at MaxMind, which is where a lot of this geographical to an IP address data comes from, they'll tell you they're not 100% accurate. Okay. Excessive permissions that can indicate compromise. Anything that's granted with star.all or star.read-write, there's over 9,000 Azure permissions. But these are some of the things you care about. That's a very easy detection rule. A wide amount of access was granted to a particular account. Now, when you integrate a cloud app into Azure, an example of this would be you're using Zoom, email, and you want to go pull data out of email to see which one of your salespeople or your professional services folks have conversed with particular clients. So you have this list of email domains for the clients that you have, which comes from your Salesforce system. And you want to know who is actually talking with those clients and when that message went out and whether or not what the subject line was. You don't necessarily care about the body of the message, but you do want that touch point automation. This is a system that goes a long way to improving the sales development process. That's a system that you can integrate. Now, there's a lot of steps it takes to integrate that, but the money maker event is when the global admin, which should be a very few number of people, actually push the consent to application function. That way, you know that that cloud app is now talking to your environment. So if you don't know how this works, you should definitely try to work with your IT team to find out when the next opportunity to observe that is in the log, because there's about 25, 28 unique events. This actually happened in the SolarWinds attack. We mentioned that earlier. A compromised certificate was attached to an application, and as a result of that, the attacker was capable of leveraging OAuth authentication to read and monitor mail. Okay. Now, for permissioned assignment, apparently it's so important that you look for anything that has a star that I put that in here twice. I got to talk to my editor, you know. But you've got the star.all permissions assignment for a reinforcement. Now, in response to this particular breach, CISA actually put together a couple of tools, Sparrow and Hawk, to help you assess the state of your application registration security posture. So there's things that you can go research, use, test against your environment to see what you have registered. AWS, tons of logs of note in AWS. You've got CloudTrail, singleton events, things you do in the user interface with your API keys, great rich log source, lets you know the IP address, the source address, the key, all that kind of stuff. CloudWatch, other events that come from other environments, you can implement that to look for performance monitoring, you know, events. You can get things from applications, push it into the central CloudWatch system. If you set up guard duty and guard duty tells you something, you probably need to pay attention to it, because guard duty is kind of like a mission specific SIM that really understands the AWS space. So if you have machines going out to malicious IPs from your EC2 instances, that's a little suspect. So you got to pay attention to guard duty. VPC flow. In the on-prem world, we get NetFlow data, Silk, all kinds of other ways to analyze that in the cloud space. There's some sort of flow log. Be aware that certain cloud service providers have different levels of flow log. If you turn the dial up to 11 in AWS, you can actually get the endpoint service attached to an IP, which is highly useful, because then you don't have to go figure out if we've made this service available at an IP address in our cloud environment. So it gives additional color to the data that you're pulling in from a flow record. You can get Route 53 resolver logs. So that might be some way where you can detect DNS exfiltration from your cloud accounts, but you got to go specifically set that up. For load balancers, obviously, you have to get exported for. So what do you do to prepare? From an AWS organization perspective, every AWS customer can have at least one master payer account. I believe that you can actually have up to 3, so you can organize that around and figure out how you're going to keep track of that. With AWS, you actually have a compelling reason to get people into a master payer account, because you pay less the more you use. And the only way for you to actually get any kind of a break on your bill is for all the individual accounts to be in an MP, because that's how the billing works. You knew the accounting people would figure into this talk somewhere, right? So you really want to get a look at your bill. I look at mine every month. It tells me that I have all these various services on board. I think last month I spent, $15, but I know exactly how I spent it because it's all listed out there, right? The other thing about having everything in organizations and master payer accounts is you can apply service control policies. I ran up against a couple of these things at the last environment where I worked. We have an SCP that requires 2 tags, and you cannot create an asset without these 2 tags. One is your general ledger accounting code. That is pretty huge. What department actually pays for this resource? Who do we talk to? This resource is involved. Tie that through your GL. From an enrichment perspective, if you can actually enrich your data, Justin's a fiend at the stuff with Logstash. If you can take those GL account codes, and then when you pull that data into your SIEM, do a lookup of the GL account code to the department name and put that in an event that's present in your SIEM or in your alert, then you don't have to go look that up manually. So that's a great enrichment opportunity if you're tagging your data with a GL account code. Don't make people go look it up, tag the data as it arrives. The other one was the point of contact. So, I had tried to create some resources and it wasn't working. And not only that, we hadn't documented this well, so I had to go figure that out. Let me think. Now, must get scripting. So again, you've got your web user interface, you've got pulling your log data. So Thursday, you're figuring out, man, the PowerShell thing's cool, but I'm going to go run an individual command to get an answer. So here what we have is an individual machine listing S3 buckets. We know that because it says list buckets is the action. And on the right-hand side, you see where it's got that little username field that begins with the letter I. I realize that's kind of small, but that begins with the letter I. What kind of a username begins with a letter I? EC2 instance. How do we make that better? Must learn JQ. JQ is an extremely useful tool. Why? Because all this data comes back to you in JSON format, which is people readable, but extremely machine readable. But what we tend to work with is list data. Here's two examples for you. Now, this one on the bottom takes the previous item and really kicks it up a notch. It says, not only do I want to know who's listing buckets, and I'm filtering that out for things that begin with the letter I, so I know that those are EC2 instances. I want to know who was denied that list bucket, and I want to know the IP address they had at that time, because if you start and stop instances, you can release IP addresses that are publicly available. The only way to get the same address is to pay for an elastic IP. By default, you get 5, right? So this is a very useful piece of data that tells me these 3 instances, whenever I ran this or whenever I pulled this data, we're using these source addresses to query S3. I can then take that and go use that somewhere else in other log data because I went and extracted it. So thinking about from an automation perspective, getting individual pieces of fact data out of JSON that we can then tear apart and go use in something else is very helpful. A few fields of note from CloudTrail. Data's in UTC coordinated time. For us, that's a really good deal. That decision was taken away from us. We don't have to worry about it. We just have to learn how to do offsets for various parts of the world. Your user identity, variety of ways of looking at who triggered that event. Event source was who created it. Then there's the user agent, consoles, applications, things like that. So detecting odd user agents, and many attack tools actually have their own user agent string, can be very helpful. When you're looking for AWS logs, you want to think about behavioral examples. So here's some behavioral examples. Remember I said I was going to talk about these. If you have a new user in your environment and their account was created and they got a role and they start clicking around in the user interface, that's going to be logged as denies. Now they're going to get a nice little red text message that says they didn't have access to it. And maybe users will do that once or twice, but if the user does that 30 or 40 times and gets 30 or 40 deny messages, what have you found? Either from an operational perspective, somebody really got the information incorrect to know what they needed, or from a security perspective, maybe you have an insider that's trying to explore. I was in an InfraGard event several years ago with a special agent by the name of Kim Embelson, who works with Justice, Main Justice. I should be really FBI. I think she worked with Main Justice, and she talked about how often an insider was involved in a white collar crime. 52% of the time. That is a scary number, very scary number. No. Creation of API keys. So there's the detection pattern is new user account is created, user logs in, user creates API keys, or you give the API keys to a user and they start immediately running commands that learn about the environment. And you have a list here for what I call the recon events. They're kind of spelled out for you. So those are great examples. If you run 5 or 6 of those in a row, you're trying to explore the environment. That may or may not be suspect, right? Some detection rules. We talked about some individual static rules, root logins, changing of the root MFA properties, things of that nature. CloudTrail changes would be another really good one. So these are great for individual atomic events. Several admin roles exist in the AWS space. Did you grant the right admin role? Did you grant the super admin role to a new user? Chances are you really don't need to do that. Chances are you can give access to very specific areas for individual users. Some other detection rules, disabling any logging monitoring function. Well, that would be bad, right? Because we're not getting any logging data. Anything guard duty, we mentioned that earlier. Cluster spin up. You tend not to spin clusters up every day. You tend to build them and then you add and remove things from the cluster because you're responding to a demand. So if someone gains access to your account and they spin up a cluster, with a bunch of EC2 instances, and those EC2 instances all are, I think it's like X4 huge period. And then there's another identifier for things that have NVIDIA graphics cards built into it. They are crypto mining for sure, and you're spending 20K a day, and you don't want that. Some hunting practices. How can you go look at this log data and do some threat hunting? You can go through and look for impossible travel, change in IPs, ASN numbers, things like that make a difference. Account bound testing. Do you know actually how to find that? Like I mentioned a minute ago. Keys, roles changing in the console, people adding and removing roles to their accounts, new account creation followed by other events of interest that look like data exploration. Can you figure those out? Can you turn these things into detections? New EC2 instances that are not the norm for your environment. You may limit yourself because of a cost model to say, look, anything above 4 CPUs and 16 gig of RAM, just as a place to talk about it, maybe require special permission or something like that. So if you see instances being created with graphics cards or hardware reservations, which are really expensive. I mean, the whole idea of cloud is I get to leverage this computing infrastructure and spend less, right? If you see things happening that violate that principle, that could be an issue. Inbound access, IPs being assigned and defined would be another really good example. For API key generation, be aware there's a JSON event that pulls data out of that, right? So you're going to get the ARN of the user who created it, create time, username, the access key ID itself, the date, that kind of thing. Most of those fields are kind of self-explanatory. And again, as I mentioned this before, when it comes to load balancers, you always really want to get the true source IP so you can connect the dots later on. When you're reading these logs, right, realize the AWS account field will trigger if it's created outside of your environment. So that's something you really want to be aware of. Your user agents tend not to change that much for user activity. So you want to be aware of that. Hierarchy or key searching. If you found a compromised key, figure out how to go back to query and CloudTrail and look for those things to see if those keys have been used. Now, another thought here is, don't just think about the cloud environment as a source. You have on your workstations, you have 2 critical files, at least in the AWS space, that we care about from a monitoring perspective, but we don't want these files to be exfiltrated. Even on Windows, it's the .aws directory. That's a kind of Linux convention, but that's actually what's created on Windows. You have the credentials file and the config file. The credentials file is just that, your long-term secret API key. So if you have the ability of detecting usage of these files, people opening up a Notepad++ every day, excuse me, ++, it hasn't gone to the third plus yet. That's 3 jokes if anybody's keeping track. So, if you can detect that from your command line auditing, and as you know, there's a variety of things you can do to capture command line audits. EDR tools, there's poor man's EDR, Sysmon. By the way, a plug for Sysmon, it actually has just been, they've just introduced the ability to block execution in certain temporary directories and folders. So if you're not paying attention to Mark Rasinovich and what they're doing with Sysmon, you're missing out. It's pretty sweet what they've done with that tool lately. Anyway, monitoring these sensitive files is an important thing for you. If you could somehow detect that someone attached it and sent it out to an email or intercept that file in an email, that would be great not to be emailing around. I would suggest that as a thought. Microsoft Azure, as it happens, Mark, now I'm not gonna try to pronounce his last name because I like Mark and he's a great guy, but Mark, who's normally at the summit, actually this year he wasn't going to be here, was pushed out an update to the GIAC advisory board list on the 20th that the Azure Active Directory Security Operations Guide has been significantly enhanced. So if this is a document that you should know about, it's got Sigma and Sentinel rules for you to go look at. Most of the stuff that I talked about from an AWS perspective is true with Azure. So we've got some numerous sensitive roles. There's thousands of permissions in Azure. It is possible to use some legacy protocols. Microsoft is really trying to push that away and not use that anymore as best as you can. The identifier for graphics machines has an N in it, and that N indicates GPU. So how to identify if people are invoking GPU-driven machines, I look for that key identifier. Changing storage accounts from public to private. is like changing an S3 bucket, creating a storage account public by default, things you care about. Oops, sorry, I hadn't advanced that page. My bad. And some evidence notes. Log Analytics Workspace is a really powerful tool. These logs can be pulled in for you, and there's a variety of pre-built queries that you can use with Log Analytics Workspaces. You should also be aware that when you interact with the Azure console and the AWS console, there's like a bash function where you can, where you can interact with a Linux shell. Some key data is saved in the bash history file, not in the PowerShell log. So, as a habit, you want to avoid, saving keys that can be, possibly extracted out elsewhere later on, just as a good piece of good hygiene, if you will. So Microsoft has come up with a number of playbooks. When I first put this together earlier this year or proposed this talk, there were 3. There's now 4. So these are some really good standardized guidance they've put together to help you deal with and respond to these particular types of incidents for you. The OPSEC guide, like I mentioned a minute ago, was just updated. That's highly useful. What's neat is for the detections that they talk about, they've added implementation for Sentinel templates. Sentinel is Microsoft's SIEM in the cloud. You get a certain amount of log data at no charge if you're an E5 customer. I preserved my email from the Microsoft sales guy that told me that for all time, made it a PDF. So if we get billed, I can go back and say, no, you said. We get some of that log data for free for 3 months. But what's also really hip is there are Sigma rules that can actually be used. Now, if you've never worked with the open source Sigma project, it's really neat. It has a rule definition and you run it through a converter. And then you can use those rules in a variety of SIEM platforms. So there's lots of smarts that have been, developed by a number of people, and that's referenced in this document. Now, I did actually mention a cloud security roadmap. So kind of in summary, what do we need for a roadmap? We have to know what attackers are doing. What are they likely to do? What's the likely cause of attack? I gave you a top 10 list of references to a variety of Microsoft attack matrices, or matrices, I should say, pronounce that correctly, that you can go leverage. Now, there's also a link here on the bottom. Somebody's actually put together a ready-made cloud security roadmap in Excel. Therefore, it's manager friendly. That's joke number 5. In case you're wondering, I'm keeping count. I want to be funnier than Eric von Bugenhardt. It's my SANS dream. Most CSPs actually have SOC 2s of that nature, so they cover it from a baseline perspective, but you're going to look in your environment and see if you're a publicly facing service, what you have for your SOC or SOC 2. For each service area, you have any idea how many services are available with AWS? It's close to 200, and it changes every week. Why? They keep adding more. Looks like the Azure people are catching up. And then trying to compare the same service with Azure and AWS versus GCP, you need like some kind of cross-index spreadsheet. I bet there's a website for that. So I think that's where I'm done. And I'm going to say thanks. And I have 1 minute and 40 seconds left. So I want you to know 51 slides, and you guys were not held up for lunch.